All right, these are your classification of matter notes. So make sure you take them down somewhere. So the properties of matter, before we can really talk about the properties of matter and classifying matter, we need to discuss what matter is. So matter is anything that has mass and takes up space. So there are 3 different states of matter that we're going to talk about. The first is solid. Solids have definite shape and volume. So those things do not change. Liquid flows, so they have constant volume, but the shape does change because it takes the shape of its container. Gas is the third type of matter, and it flows as well to take the shape of the container, just like liquid. And it fills, that's the word we're missing here, flows to take the shape of the container and fills the entire volume of the container. So if I pour a glass of water, the water will only be, like if I only pour half of it, then the cup will only be half full. But if you put half a cup's worth of gas into a cup, it would fill the whole container. It spreads out, or it can be compressed. All right, so here is a picture image of that. So solids are rigid, fixed shape, fixed volume. Liquids, not rigid, no fixed shape, but still fixed volume. Gas, not rigid, no fixed shape, no fixed volume. All right, so whenever we're talking about matter, we can talk about its different properties. The first are the physical properties. So a physical property is a characteristic of matter that can be observed or measured without changing the sample's composition. So that's the important part. So if we're measuring or observing it, then we're not changing what it is. So some examples are density, color, odor, hardness. So that's mostly when you're talking about things like metals, melting point, and boiling point. Chemical properties are observed during a chemical reaction or transformation. So things like iron rusting, iron under nitrogen is also a chemical property. So you're looking at what is happening and how something is chemically changing. So I want you to pause here and in your notes classify each of the following as a physical or chemical property. Iron and oxygen form rust. Iron is more dense than aluminum. Magnesium burns brightly when ignited. Oil and water do not mix. And mercury melts at negative 39 degrees Celsius. So take a moment. Okay, so just to check our answers, iron and oxygen form rust. That would be a chemical change, right? Because now we have iron oxide. It's a new compound, a new chemical. Iron is more dense than aluminum. So you're just looking at density. Density is a physical property. Magnesium burns brightly when ignited. Okay, so we're setting this on fire. It's something new. It's definitely a chemical property. Also, fun fact, magnesium is the active chemical in fireworks. So whenever we're talking about it burning brightly when ignited, that's what we're talking about. Oil and water do not mix. All right, so that is actually a physical property. You're looking at the densities, so that's why they separate. And then mercury melts at negative 39 degrees Celsius. So melting point would be considered a physical property. All right. I'm going to talk about why. So a physical change is a change which alters a substance without altering its composition. So like we said, nothing is chemically changing. So tearing paper, you still have paper, it's just in 2 pieces. Ice melting. So ice is just solid water. So all it is going from solid water to liquid water. So that brings us to a phase change is a transition of matter from one state, like a solid, to another, like a liquid, and is considered a physical change. All right, which is, it feels a little backwards when we're talking about things like melting point and boiling point. You want to say, okay, if it's melting or if it's boiling, that's chemical. But it's not, because it's still physical, because nothing is actually happening with the atoms, right? Their energy is being added or taken away just to make it in a different form, but it's still chemically the same thing. So chemical changes is when a process that involves one or more substances changing into new substances, and that always produces a change in properties. All right, so for example, whenever food gets spoiled, so I'm going to think of milk. All right, so as milk becomes spoiled, there are chemical processes that are happening, making new compounds from the old compounds. And if you think about some properties that change as a result of that, there's usually smell. You get some chunky things that happen. That's also a change in property. So you start to see different properties change as chemical changes take place. So when we're talking about chemical changes or chemical reactions, we talk about it in the terms of reactants, which are the starting substances, so what you start with, and products, which are the substances that are formed, or the resulting the things that are produced. So it's always important when we're talking about chemical changes to discuss the law of conservation of mass. And all that says is mass is neither created nor destroyed during a chemical reaction. Okay, so no matter what's happening, the mass we start with is going to be the mass we end with. Okay, we're not, superheroes creating things or destroying things into the abyss. Matter always turns into other matter, even if it looks different. All right, so how are we classifying matter? So we can talk about it in terms of elements versus compounds. So an element is a pure substance that cannot be separated into simpler substances. So these are the things we find on the periodic table, and they are the most simple building blocks of all of matter. A compound is made up of two or more different elements that are combined chemically. So whenever I'm talking about combined chemically, I'm saying that they are bound together. All right, so earlier we talked about how water and oil are mixed. Those aren't combined chemically, they're combined together in the same container, but the water is separate. It's not bound to the oil. Okay, so a compound is when they're bound together. You can also have mixtures. So that's like the water and the oil, a combination of two or more pure substances in which each substance retains its individual chemical properties. All right, so an example is an Italian salad dressing. I don't know if you like salad or if you like Italian salad dressing, but most of you who have seen it know you have to shake it up before you pour it on your salad because it separates out. Everything is you still got your little pieces of pepper, and you have your oil and vinegar and all that kind of stuff. And so it's just shaken together to put on your salad. So there are two types of mixtures. We have heterogeneous mixtures, which do not blend smoothly throughout, and the individual substances remain distinct. So that's just like the salad dressing. Another example would be a fruit bowl. So if I have a bowl of fruit, I have strawberries and blueberries and raspberries, I can go in and say, Miss Harvey really loves strawberries. I'm going to take those out. All right, so I can take my individual substances because they're still distinct. The second type of mixture is a homogeneous mixture, and those have constant composition throughout. Okay, so if I take that same fruit bowl, I dump all that fruit into a blender, I make myself a fruit smoothie, then I'm going to get the same taste if I taste at the top of my cup or at the bottom of my cup because it has a constant composition throughout, right? Or a uniform composition throughout. So when we talk about separating mixtures, we can separate mixtures a whole bunch of different types of ways based on their different physical and chemical properties. So some examples, if we're talking about solids and liquids, generally we can filter those. Okay, so like if you think about water and sand, if you put a filter and you dump a mixture of water and sand on it, the sand will stay on top of the filter and the water will go through. If we're talking about separating two different liquids, we can separate them based on their boiling points, which is something that we call distillation. And this is actually a very popular method of purifying or separating different liquids. So if you go to the store and you get a gallon of distilled water, all that means is that it was boiled exactly to 100 degrees Celsius. And so the water evaporated, and then they cooled it over to the side, and it dripped back down in water form, so that any other impurities that don't boil at 100 degrees Celsius, they actually stay behind. So it's a very reliable way of separating and purifying different liquids from each other. All right, so make sure you have all of these notes written down, and that's all we got for classification of matter.